morning. So let me make sure that I'm really happy that I get this platform this year because last year I was like down here. So thank you for this platform. Now I feel a little too tall, so you can't, I guess, yeah. Good morning, everyone, and thank you so much for having me here today. And thank you so much, React Rally, for getting me back here. My name is Shirley, and I'm an independent creator of data visualizations. I had the pleasure of being here last year to give this talk called D3 and React, where I talked about when we might use React with D3, which is when we want to componentize visualizations and manage the state as the user interacts with it. And I also went through the two different ways that I use React and D3 together and their pros and cons. I had a really great time, and you gave me such great feedback afterwards. And two of those feedbacks in particular stayed with me. The first was that you told me that you liked what you saw and that you wanted to build data visualizations too, but that you found D3 a little bit intimidating. And I heard this at multiple different conferences. The second is that you told me even if you could D3, you weren't quite sure how to get from those common D3 charts that you see in example libraries to building your own custom data visualizations. And this feedback really stayed with me because I firmly believe that the practice of building good data visualizations is not an engineering problem. Rather, it's a design problem. And so for the past year, I've been thinking a lot about these 2 points. And I'm really excited to be here today to share with you my semi-conclusions at this conference that started it all. So let's get started with D3. I think there are 2 reasons that D3 can be hard. The first being the enter, update, exit pattern, which is oftentimes the very first thing we encounter when we're starting with D3. And the second is just the sheer size of the API. But I want to show you that React actually makes getting into D3 really easy. The enter, update, exit pattern is D3's way of going from an initial state, we'll call that a state A, to its next state, a state B. And the way that we do this is that we, as the developers, have to remove from the DOM what was in A that's no longer in B, and we have to add to the DOM what's new in B that was not in A. And finally, we have to update the attributes of the DOM elements that remain from state A to state B. And as you can probably imagine, that having to do all of this and manage all of this can get really confusing, especially for more complex visualizations. But you might also have noticed that this process sounds quite familiar. And that's because this is theoretically exactly how React's virtual DOM works underneath the hood. So instead of using D3's enter, update, exit pattern, let React's render function do all of the hard work, the hard lifting for you, and managing updates and re-renders to the DOM. The second thing that people might find intimidating about D3 library is just the sheer size of its API. If you've ever been to the D3 website and scrolled through the documentation, there's a lot of modules and functions in there. This is my attempt at organizing all of these modules into sections, into the order in which I might use them when I'm creating my data visualizations. I want to concentrate on just these sets of modules because these are the ones that I use the most frequently. These are modules like the scale module that help me translate raw data into screen space, into XY positions, into width, height, into angle and radius, into color. These are the force and hierarchy modules that help me calculate the XY positions of each of the nodes in a network diagram, in a tree map, a circle pack. Similarly, the geographies module help me calculate the XY positions for each of the states, the countries that I want to draw on the map. And the chords and shapes modules help me calculate the SVG and canvas path commands necessary to draw the ribbons in a chord diagram, a line chart, a pie chart, an area chart onto the screen so that I don't have to. D3 also gives us modules like brush, drag, zoom, and pan to help me implement interactions that are really common in data visualizations. These modules, to me, are the unique selling points of D3. I think they are what makes D3, I think D3 does this better than any other library. So if you're just starting out with D3, I would encourage you to start by looking here. And to make your life easier, use D3's scales, shapes, layouts to translate your raw data into screen space. But use React's render function to do the actual drawing of that translated data and managing of the updates and renders to DOM. And I hope this convinces you that D3 is actually really easy to get started in if you're already a React developer. But just knowing D3 isn't enough for creating good data visualizations. D3 is a really great tool for creating visualizations for the web, but there's a whole process before that of analyzing the data, of designing visuals for that data that makes sense. And for the past few months, I've been really obsessively thinking and researching into this, trying to figure out a loose set of steps that I can apply for each new data visualization project. And to share that process with you, I want to go through this data set of the top 10 blockbusters movies of every year for the last 2 decades and create a custom data visualization. So let's get started. The very first thing I do after I get my data set and I clean it is I like to list out all of the attributes of that data set. And I like to note down what kind of data type those attributes are, whether categorical, quantitative, temporal, spatial. And I also like to mark the ones that I find really interesting. So for our movies data set, this is the list of all of the attributes. In particular, the categorical attributes in there are the ones like genre, director, writer, actors. I have quantitative attributes like Metascores out of 100, number of IMDb votes, box office figures. And I also have temporal attributes, like when the movie was released, as well as when it was released again in DVD. I can take this list of attributes and zone in on just the ones I marked as interesting to help me formulate some questions. For this particular exercise, I'm going to concentrate on just 3 of the ones I marked as interesting: the attributes released, Metascore, box office. And with just these 3 attributes, I can come up with some questions that I think are really interesting, some curiosities. I can ask, when are most blockbusters released? Is it in the summer, during Thanksgiving and Christmas holidays? What is the distribution of the Metascores for these movies? Do these blockbuster movies tend to score higher? And is there any correlation between box office and Metascores? Do movies that do well in the box office tend to have higher Metascores? I can then take these questions, these curiosities, and let them guide me when I'm exploring my data. And when I start exploring my data, I like to get them onto the screen as soon as possible, either with D3, Vega Lite, Python, R. I would encourage you to use any of these, Tableau, any other charting libraries, to get them onto the screen so that I can see the shape of the data and find any potentially interesting patterns and insights. For our movies data set, I plugged that in to a bar chart, which is really, really great for categorical distributions. And you can immediately see the two peaks that are very obvious. One's in the summertime, in the May, June, July months, and again in the winter, in the November and December months. To answer the question of when are the most blockbusters released, I used a histogram, which is really, really great for quantitative distributions, to look at the distributions of the Metascores for each of these movies. And you can probably tell that these movies apparently don't actually tend to score that high. And actually, most of them fall between 40 and 80 out of 100. And finally, I plugged the data into a scatter plot, which is really great to see correlations between two attributes to help me answer the question of, do movies that do well in the box office also tend to have higher Metascores? And you can see that the points are actually just straight and up and down, and there really isn't much of a correlation. But it's really helpful to be able to see these visually and make conclusions, get conclusions out of my data, so that I can use those findings to form a message that I want to communicate with my visualization and design my visualization with that message in mind. That blockbuster movies are highly seasonal, and that the highest box office figures were during the holidays. So now that we have a message that we want to design around, let's work on translating that message into visuals on the screen. And for that, I love the concept of marks and channels. The way I think about them is that I map individual or aggregate data elements to marks. And I map my data attributes to channels. Marks are these geometric shapes like points, lines, areas that I can map my elements to. And for channels, for quantitative attributes, I like to use the channels of XY positions with height radius, sequential and diverging color schemes. And for categorical attributes, I like to use shapes and discrete colors. So this is my chicken scratch design for our movies data set. Down here, I have the histograms that show the distribution of just the box office and Metascore. And later on, I want to implement an interaction, a brush interaction, to help me filter the movies. But today, I want to concentrate on this custom part up here. So let's break it down together. The marks for this visualization is this kind of weird curved area thing, and each of those represents one movie. And I've assigned release dates to the X position. I've assigned box office figures to the Y position, with a slight twist that any movies with the box office figure above the median will rise up, and any movies with a box office figure below the median will droop down. And I've assigned Metascore to a sequential color scheme. And finally, I have these little markings up here that indicate the summer and winter months so that we can see easily if any of the top peaks overlap with any of the holidays. And now that we have the design, I want to code it together in D3 and React. And so to save time, I already have the histogram coded up. So let's concentrate on just this part. At the base of it, this visualization is made up of these little curves, and we can make these curves with a D3 area generator. And the way that D3 area works is that you can give it a series of points, and then it goes and draws a line between those points and then fills in the area underneath. So for us, we want to, for each movie, give D3 area 3 points, one in the middle, whose X position is the release date of the movie, and the Y position is the box office figure subtracted by the median, and 2 on the sides, 1 2 months before the release date and 1 2 months after, with the Y being just the median. And this is where I'm going to do my live code, so please wish me luck that it goes smoothly. Thank you. and that the bugs are easy. That's all I can hope for. So this is my code. This is my app.js. And in here you can see I just have some states. I went in and I loaded the data. And I have just my area chart and then the 2 histograms that you see here already there. And I'm going to go into my area chart and get derived state from props. I'm going to calculate my data. And I'm only doing this in here because it's the most straightforward option. So let's start by calculating the median box office that everything is going to be based around. So to do that, I want to do median box is equal to D3. And then I can say median, pass in the movies data set, and then tell it to use the box office figures for the median. And then I'm going to need to calculate my X scale. And for that, I want the min date, the max date, and to get that, I can use d3.extend, pass in the movies, tell it to use the dates, create the X scale with D3 scale time. Dot domain is I want to offset my min date by -2 months, and I want to add 2 months to my max date, and I want to map those 2 dates to an output on the screen of, to the left, I want margin.left, and to the right, I want width minus margin.right. That's my X scale. And then let me go and create my Y scale. To do that, I want to get the min and max for the box office. But here, I want to subtract that by the median box office. And to create the Y scale, all I need is scale linear, give it the domain I just calculated, and map that box office min and max to the bottom, so height minus margin dot bottom, and margin dot top. And then finally create a color scale, and for that color scale, I want to use a sequential scale and pass in a color scheme that's called Veridis. And then, I jumped ahead. For the color scale, I want to use the min and max metascore. So go out and get that, d.score, and then grab the domain and set it as the score min max. Create a D3 area generator and tell it where its baseline should be. And that baseline should be the median. Y scale is 0. And now we have everything to calculate the arcs that we need. So let's do that. So let me use Lodash to chain the movies, and then sort all of those movies by math.absolute and the difference between box office and median box office, so that my tallest peaks and my lowest valleys can be all the way at the back. And then let me map each of those movies to an arc, and so I want to calculate the path of each of these using the D3 area generator I just created. And like we mentioned before, I need to give it 3 points, the first being the x position being month.offset, and 2 months before our movie's release date, the y scale being just the median, and then the middle point being the release date itself with the y scale of d.box office minus the median. And then one last point, that's just 2 months after the release date. And then, where did I say median? Oh, median box. Thank you. And then fill, I want to just color it by the color scale, pass in the score, and then pass that, return that as state. And if I did all of this correctly, then I can console log this dot state, and oh no, I need to do dot value to get it out of there. And then hopefully, there we go. And we have the path strings that will make the shapes. Oh, thank you so much. And the fill. And thank you. And that's all it took to create that data, but we don't have anything on the screen yet. Let me loop through all of those data. And for each one of the arcs, create a path element that takes in d.path for the strings, for the command to draw those paths, and fill it by the color we already calculated, and stroke it by white so that we can see the overlap. And that's all it took. But we're not done. We're not done. This is just part 1 out of 3. But you might notice that it's quite spiky, and spiky is kind of mean looking, so we're going to make it into the curves that I drew earlier. And to do that, all I have to do is go back into my D3 area generator and tell it the curve I want. In this case, I like to use curve capmo rom. They have weird names. I don't know. I'm sorry if this is a researcher I've just offended. And now you can see with just that one line that I turned into a curve. That's all it takes. Isn't that really cool? That's all it takes in D3. But you might notice that I just have a bunch of curves, and we don't know how to read it. It doesn't have any markings. So let's go and create some axes for this visualization. And I want to show you how easy it is to do that also. So up here, I've already defined some D3 axes, and I've initialized them. And in my render function, I have some empty group elements. And I can just, in my component did update, set the scales that I just created in my, and I need to pass that. Let me pass that. And so I need to set these scales. And then all I have to do is say select that group element I created, call call this dot x-axis. Nope, x-scale, this dot state dot x-scale, thank you. And that's all it took. Look at those nice years at the bottom. And let me do the exact same thing for the y-axis. I'm just gonna copy and paste a bunch of things. Y scale, and copy this over. And then put some y-axes in here. And that's it. Just that. That's all it takes. It's so cool. So now that we have the basic visualization, I want to consider some interactions. Putting in some interactions into our visualizations, but only if it makes sense. And for us, for this movie visualization, I want to have a hover interaction that shows the details of these movies. But I also want to have this brush interaction that helps me. I just heard an oh my god. That helps me filter down the movies by Metascore or box office. And I think this adds a really great another dimension to our visualization. And this might look like it might be really, really complicated to implement. I want to show you right now how not complicated and how straightforward it is. So let's do this. To create this brush function, I'm going to go into my histogram component. And then here in component in mount, I've already initialized D3 brush. And all I have to do is down here, I have an SVG group element, an empty one. And all I have to do is use D3 to select that select that group element, call this dot brush. And now we have that rectangle and the drag functionality. Just those few lines, and we have this. But you might notice there's no filtering yet. And that's because we have to go and implement that ourselves. So let's do that. I have this function down here called brush end. And what I need to do is figure out the bounds. You might have noticed that these rectangles have a left bound and a right bound. And what D3 does is it gives me the x positions of these left and right bounds. And it's stored in this thing called d3.event.selection. So then I can go and extract that. And then I can say, ooh, I need to use let. Hold on. Then I can say my bounds, I want my bounds to be this .state.xscale.invert x1. And what invert does in xscale is it helps us translate from the range back into the domain. And so in this case, it will help us, given an x position, give us back the domain, the box office or Metascore. So let me do that same thing for x2. And then I'm going to call this update filters that was passed in from my app.js. And I'm just going to give it an object where the key is the attribute. In this case, it's either score or box office. And the value is the bounds that I just calculated. And if I did this correctly, then up here in app.js in update filters, I can console log the filter. And every single time I do this interaction, it should give me score and the bounds. So the lower and upper bound of the score of this rectangle. And similarly, I can do that for the box office figure. And these are the min and max. With that, let me go and calculate the new set of filters. And I'm just going to do this by getting the old set of filters and then putting the new filter in. And I also need to calculate the filtered set of movies. So let me do filter this.state.movies. And for each movie, I only want to keep it if for every single one of these filters, these new filters, it is either the filter doesn't have bounds or that the attribute for that movie is within the bounds of that filter. So, and d.attribute is less than the max. And if I did that correctly, then I should get, every time I do this, I started out with 98 movies, and every time I filter, now this time I have 48. When I do this, I have 45. If I do this, I have 34. So I've done this correctly. I want to set state on those new filters and the filter down movies. And now all I have to do is go into the area chart, and instead of creating the arcs with all of the movies, I just used the filtered down set of movies. And it filters. Thank you. Thank you. And in the histogram, instead of binning by all of the movies, if I just bin by the filtered set, and now these will update accordingly also. And that's all it takes. That's all it takes to make this brush interaction. It's super easy with React and D3. So finally, after all of these base visualizations and interactions, I want to also make sure that my visualizations are readable. So I'm going to put in titles, descriptions, axes, legends, annotations to help my readers, to help guide my readers through how to read the visualization, as well as how to interact with it. Oh no, this is what I didn't want happening. Okay. But I have a solution. Hold on. I'm gonna git reset hard, and then I can git check out my movies branch, and then I can just go back to here, and that's my solution. And as you can see, some of these highest peaks, so this one in particular is Star Wars The Force Awakens, which made nearly $1 billion in the box office, overlaps with the winter holidays, and so does this one, the Avatar that came out in 2009. And that's really cool to see. But the funnest part of this visualization is that if I have a curiosity, let's say I want to look at all of the movies, the blockbuster movies, that did relatively well in terms of Metascore, but did below median on the box office. And I can go in and take a look and see that's The Martian, that's Inside Out, and that's WALL-E. But look. WALL-E has 95 in Metascore. That's awesome. And this is all inflation adjusted, by the way, so that's sad. Yeah, that is sort of sad. I'm sorry. And conversely, I can look at the ones that, didn't do so well with the Metascores, but still did above the median in the box office figures. And that's ones like Transformers, and Transformers again, and the Twilight Saga. Thank you. So I hope you can see, it's so fun. It's just it's so fun to look through these visualizations and build them, explore them. But I hope I was able to convince you today that using D3 and React together is actually really easy. And I hope I was able to give you some guidelines on how to create custom data visualizations. But I've just scratched the surface with this talk. So if you're interested, I've recently created some courses on Front-End Masters that goes and dives really deep into all of these topics I covered today. So I hope you'll give them a chance and check them out. And I hope that you fall in love with D3 and data visualizations. But most importantly, I hope you'll join me and help me in building custom data visualizations for the web a more common occurrence. Thank you.